Good afternoon, everyone. I'm Shannon de. Welcome to today's webinar on Gabion Solutions and Innovation, hosted on behalf of Gabion Baskets, a top player within South Africa as well as the African continent. Gabion Baskets specializes in the manufacturing of quality Gabion products, equipment and services that is crucially important to the civil engineering, mining, architectural and building industries. Today's expert panel will cover what they are, how they're made, and why they're becoming a go-to choice for landscaping and construction. Before we start, please note that the chat and the Q&A are available to you. Please post your questions in the Q&A and your comments in the chat. Both the Q&A and the chat are at the bottom of your screen. Please be aware that we're recording this webinar and we'll send the recording to you when it's available. We're also streaming the webinar live on YouTube and we'll share the link in the chat once it's available. So let's get started. Today's moderator is Cheyne, MD of Gabion Baskets. Cheyne is passionate about advancing industry best practices and is dedicated to continuous improvements and innovation in Gabion technology. His expertise encompasses project feasibility studies, design calculations, and construction oversight, enabling him to guide projects from conception through to successful completion. He will be in discussion with Cheyne, the General Manager of Gabion Baskets, and Fanie Joubert, the MD of Civil, Structural and Eco-Engineering. I'll hand over now to our moderator, Cheyne, to start the discussion. Over to you, Louis. Oh, Louis, you're on mute.
Okay, you can hear me now.
Yes, all good.
Okay. Let me start again. Good afternoon to everybody. Thank you, Shannon, for the wonderful introduction. We really appreciate the opportunity to talk about our passion, gabions and solutions and design and installations. We have lots of things to talk about today, but I'll start by introducing the team that's going to be speaking today. Myself, Cheyne. I've been in the Gabion industry for the last 33 years. I started off in the Gabion industry at the age of about 28 in 1992 with a company in Durban called African Gabions as a sales rep, technical sales rep for the whole of Southern Africa and the Indian Ocean Islands. And then I became technical manager about 3 years later, for about 3 or 4 years. And then I moved to Johannesburg and I started up a different company about 7 years later called Land Rehabilitation Systems, also offering the same sort of services from 1999 to 2006. And then Gabion Baskets was formed by me and the owner of Bonds Fencing in 2006 to integrate a lot of other systems into our product portfolio that we felt were important, like welded mesh, like installations, and like full design and better service to our clients. My 2IC in my business is Cheyne. He's been around about 10 years in our business, and Fanie Joubert, our guest speaker from Nelspruit area, is a civil engineering technician like myself, with many, many years of experience, both design, practical, installation, selling. We have a really great team of people that are very passionate about what they do. This is the sort of thing my son Clinton does. He's an animator and a 3D visual artist. He can take photographs and superimpose designs of Gabion systems on these photos together with measurements to give you a very good idea of what your structure might look like once it's been built, because sometimes 2D plans can't give you an idea. 3D visualizations are actually quite important for them, becoming more and more popular. This was a job that I was involved in with Fanie Joubert, our agent in Nelspruit, probably about 24, 25 years ago in Cheyne, when he was a consulting engineer in Harrismith. We were doing some very interesting projects. What? I'm not sharing my screen. Share. Sorry, a bit of a glitch there. I wasn't sharing my screen nicely. Just to continue. So this project in Harry Smith was a project that I assisted Fanie Joubert, our agent in Nelspruit, at the time, about 24 years ago, Gabion structures to hold up a suspended concrete bridge with bridge abutments along the structure. Very nicely done. So Fanie's been around a long time. Gabion Baskets offer sustainable construction solutions, as we've been in the industry for over 30 years. Generally, we like using locally sourced labor and materials to create environmentally friendly structures. And we often designed an innovative design of our structures using best labor practices and design strategy. Some of our structures we build are very environmentally friendly, where we incorporate the design of these structures into where? Yeah. There. Is it right now? Just come and have a look, Steph. So since 2006, we've been specializing mainly in the civil engineering and mining applications. Where?
Just stop sharing.
Yeah. At the bottom.
Or, yeah.
More.
Stop sharing, Mr. Cheyne. Sharing, green. At the bottom, green one.
Yes.
And then just select the presentation.
This one.
The presentation, yes. There you go.
Yeah, now I'm all right now. Thank you, Steph. So as I said, we originally started with the civil engineering and mining side of the business. But about 10 years ago, we started creating products that are now used quite widely in the building and architectural industries for retaining walls and river diversion structures and river soil erosion protection. Gabion baskets have been manufactured by materials. Yes.
Sorry, I just want to jump in quickly. We're just seeing your computer screen and not actually your PowerPoint. Would you like me to share on your behalf?
You must click on share.
Yes, please. Otherwise, I can share on your behalf.
Am I correct now?
No, I'm still just seeing your computer screen. There we go. Can see it now.
Is it right now? Okay, thank you for that.
Yes, we can see your PowerPoint. Thank you.
Thank you, Shannon. Okay, so we do tailored solutions for specific structures and for different clients in Southern Africa. And we manufacture our baskets in Johannesburg. We've got branch offices in Durban and Cape Town, where we distribute from. Our manufacturing happens in Johannesburg. So we offer structures like this to the industry, which was a mass gravity retaining wall structure built in Silver Star Casino about a year and a half ago now, where we built a 9-meter high structure, mass gravity based with probably about 4 to 5 meters, found to 10% of height with the woven mesh gabion structures. And this we do quite often. The most popular use for gabions are mass gravity retaining walls. Okay, what is a gabion? A gabion is basically a cylindrical or square container made out of woven or weld mesh material containing rock. Now, there's a lot of different types of rock, and obviously the rock you choose is quite important. We don't want to be using soft sandstones and shales for the inclusion into gabions. We want to be using the solid parent rock, granite, dolerite, tillites, basalt, that are very high strength, minimum 2.6 tons per cubic meter density to give our gabion a weight of about 1.6 tons bulk density per cube. So this is why they work so well, because they contain rock and really function very well internationally. Gabions have been around a very long time. Historically, the ancient Egyptians used them. In medieval times, they used them during battles. They used to make cylindrical ones out of wicker basket material, tie them together, and then fill them with rock for fortifications, and even rolling them down the hill against the oncoming opposition. So this has been around a long time in South Africa. Gabions have been around since about 1957. Internationally, the new type of woven mesh gabion has been around about 130 years. Our raw material is made in a blast furnace using either a portion of recycled steel or virgin iron ore. And then we create big billets out of them, which is billets. You can see these billets, they come of size 120 mil by 120 mil square, and then that's drawn with high pressure and high tensile strength to create wire rod, which is 5.5 millimeter wire diameter. And that rod is used for two purposes. It's used to draw wire from for the fencing and netting industry, like our baskets, and also for the reinforcing industry. Okay, gabions have obviously been used throughout the world, predominantly in Italy and North America, and even Australia and New Zealand. So it's an international product. It's served its purpose, and we've still got beautiful structures. I've seen structures in northern Italy over 100 years old that are still covered with riverbed sediment and performing their task quite amazingly after a long period of time. Okay, why do people use gabions? One of the most important aspects is the labor-intensive nature, because you can fill the gabions with machinery, but it's better for the packing and the visual finished product purpose to use labor to pack the baskets by hand. So we say 1 man per cubic meter per day to pack the baskets, generally as acceptable. They're environmentally acceptable because we can grow these structures with vegetation on the top, through the structure, or even underneath the structure, to make them blend in with the surrounding environment in a better way. They're highly economical, especially if you're using the local labor, unskilled labor, and you're also using local rock supplier from a quarry which is close to the project. It can bring down the cost of gabions quite significantly. Obviously, gabion is a simple product, but we have lots of tricks to design, obviously lots of experience to design the structures correctly, and to make sure that they're built correctly and they're structural sound over a long period of time. They're highly natural, made from local stone, durable and flexible. The mesh is class A galvanized, low tensile strength, mild, heavy duty galvanized, so that they're flexible structures. With the woven mesh and rigid square weld mesh materials for the architectural industry. The other thing about gabions, which is a big plus, is their permeability aspect. With concrete retaining wall structures, you need weep holes through the structures to allow for hydrostatic pressure release through the structure with high amounts of rainfall. Gabions is a totally permeable structure with a void ratio of about 35% void, 65% solids. So they actually work quite well to drain the embankments behind them and not allow any hydrostatic pressure buildup behind these structures. Very high strength with the 80 by 100 millimeter hexagonal double twist steel mesh that we use in the gabions can withstand a tensile force of about 3.4 tons per meter UDL, or about 34 kilonewtons, which is quite high. Sorry, let me just go back again. Soundproof, because of their very rough and porous nature, they tend to absorb sound much better than concrete, which reflects sound. So in a situation where you're next to traffic or a building or industry that makes a lot of noise, the gabions are very well suited to dampen the sound coming through. And then bomb and earthquake proof, they've been well proven because of their flexible nature in earthquake environments, to be able to move and settle and not fail. So that's also quite important. We even have military defense barriers that we use now too, which will be shown to you a bit later. So we have the two different types of mesh that we use. The hexagonal double twist mesh on the left-hand side here, 80 by 100 millimeter aperture, 80 across, 100 height. So because of the size of the mesh, you need a certain size of rock so it doesn't fall out the mesh. Minimum size rock of 100 millimeters for this type of mesh. And then on the right-hand side, we see the square weld mesh that we use, more for architectural purposes. The tolerances are much tighter and much better in this. And obviously with the thicker mesh, these baskets are much easier to install with the square weld mesh than the woven mesh, because with the woven mesh, you need a lot of bracing and support and tensioning with this mesh to make it more rigid so that you can fill it with rock and it doesn't bulge. So those are the two main types of mesh we offer. The left-hand one, the hexagonal woven mesh, is used in the civil engineering and mining industry, and the square welded mesh is mainly used in the architectural industry or near buildings or homes where you need a nice looking finish. Okay, we obviously have our mesh specifications with the mesh wire for the gabions and the mattresses. A mattress is just a flat gabion. You have the maximum thickness of a mattress of 300 and the minimum height of a gabion being either 0.5 meter or 1 meter high. So these are just some of the tolerances and spec which we can let you have afterwards, which shows you the correct wire diameter, the tolerances, the tensile strength of the mesh, and the breaking strain of the mesh once it's woven. The square weld mesh we supply is either 3 or 4 millimeter wire diameter. All of our gabions are heavy duty or class A galvanized. With the weld mesh, the square weld mesh type, we either have a 50 by 50 mesh opening, 50 by 100 mesh opening, or a 75 by 75 mesh opening. This is the one that's catered for in the SANS specification in South Africa for weld mesh gabions, a 75 by 75. But we found that the 50 by 50 and 50 by 100 is slightly more rigid. So with the thicker wire diameter, it's much easier to fill and quicker to fill using a slightly smaller rock. You don't have to pack it. You can pour the rock in, which makes for much quicker installations and much better looking front faces because it doesn't bulge so easily like the woven mesh. And this is why we use it more for architectural type structures where you need something beautiful. It's not just in a river where you don't really mind the woven mesh not looking as good. We have 3 different types of galvanizing. We have heavy duty galvanized. We have Alu zinc, or we call it aluminium zinc, which is we currently supplying 90% zinc, 10% aluminium alloy coating for areas of corrosion, or you can even use the 0.5 millimeter thick PVC coating on your gabion mesh as well, and the square weld mesh. So the class A galvanizing is the normal gabion we supply, and then with PVC coated, it takes the price from about 40 to 50% more expensive, and then a minimum design life of the PVC coating to be about 60 years. With the Alu zinc and PVC, we can get to 120 to 200 years because the lifespan of the galvanizing is then at least double or trebled. So as you can see, the galvanized is the cheapest mesh. Alu zinc is about 10 to 20% more expensive, and the PVC coated is around about 40% to 50% more expensive, depending on what you need, depending on your environment, if you need something to protect against corrosion. These are standard gabion sizes. Because hexagonal woven mesh have been around much longer, we have quite a range of sizes. The weld mesh sizes, it's not such a big seller yet. We mainly supply that in mesh rolls for clients to build structures when we build structures. And as you can see on these sizes, these 1 by 1 by 1, that's 1 meter by 1 meter, 1 meter. So that's 1 cubic meter of basket there. This is the most common size basket, a 2 by 1 by 1, 2 cubic meters there, for about 3 tons of rock required, and 2 man days for one of those. So all of these, if you just times them, you get the volume of the basket. So all of these are most popular, used in the industry. Gabion rock is also very important.
Apologies, everyone. We seem to be experiencing some technical difficulties. I'll just give Louis a couple of minutes to see if we can get him back online. Clinton, are you still there? No, it looks like we've lost them. Fanie, would you like to perhaps continue with your section, and then we can come back once Louis and Clinton have managed to come back online?
That's 100%, Shannon. I'm ready for you.
No problem. You can
Just
start
share
sharing. And if you
Right.
have any trouble, I can share from my side.
Let's see. I think it
Okay.
will share. Okay. Okay, can you see, Shannon?
Yes, we can see it's come through.
Okay. Thank you, Shannon. Good afternoon, everybody. I just want to give a special thanks to Gabion Basket Management team. For the past 15 years, we worked close together, and I enjoyed it thoroughly to work with them. My start in Gabion Baskets was, like Louis said, about 20 or more years ago. And becoming an agent, my first sale was 2 by 1 by 1 baskets. So I was very proud about that. But then it snowballed and it got larger, and the clients started to ask me if I can also install this stuff, and I said yes, I can do. And one client contacted me. We will look at that project just a little bit later. That was the most difficult start, I think, that you can have. You will see on the next slide that it was a failed Gabion structure. But passion as a way of outshining inexperience, and I said, yes, we can do that. And the biggest lesson I learned from that whole experience was that planning, you can't skimp on planning. Everything is, planning is everything. So I did a detailed survey of the area. You will see that also, and calculate the volumes. And because it was a failed structure, we had to recover some rock, and so we had to estimate how much rock we will be able to get back, and how much we'll have to import. So it was a very tense situation for me, because we couldn't make any mistakes, and the rock has to be imported from quite far away, so it was really expensive.
Fanie?
And yes.
Sorry, I'm just going to quickly stop you. Our audience has requested that you put this on presentation mode, as they are just seeing all your notes. Would you like me to share from my side?
Yes, yes, you can.
Okay. Sorry, everyone. I'm just going to quickly share Fanie's presentation from my side. And then Fanie, you can just tell me when you need to go to the next screen.
Okay, Shannon, thanks a lot. Okay, so you can maybe go to the next slide now, where we can dig into the details of the first project. Are you ready, Shannon? You can maybe skip that one also. Okay, that's the introduction. Like you see, okay. Yes, there's our next the first project, which I would like to show you. That was a project in the Dolstrom area. You can see this is a failed Gabion structure, which happened due to one simple detail. That was my what I think what happened was, because there was no mattress installed on the bottom of the structure, and there was like a solid slash type foot base which they used, and which couldn't manage the stormwater. According to the client, when in full flood, all those 9 Omco culverts is full of water, is full to the top. So the installation just couldn't handle the flood. So and we had to take out, we had to salvage some of the rocks as much as we can. And you can see on the pictures that on the far side of the left-hand picture that you see now, that was the original structure. And so it took out some soil, a lot of soil, which we had to replace with the gabions. And so after the project, the client mentioned that he had some big contractors looking at the job, but nobody came back, and we were the only ones that was actually interested to do the job. And it was very tight schedule that we worked on because of the location of the site in the we had to do it in the dry season, finish before the rain started. And so we managed, and we I think it was a successful project that we managed to do. And so then we continued, and we did the gabions and the slab on top. So and afterwards the project was really successful. So Cheyne, you can maybe go to the next. Okay, this was quite interesting project. This is in the between Nelspruit and Kaapsehoop. You can see on the first on the picture on your left hand side that we did also what I learned from my first installation is proper planning. So we did a really detailed survey of that donga. It took us a while, but we did a very detailed survey, and we managed to I managed to do a layout to use existing solid rock, which I used to anchor the structure. And I proposed to the client that we do a check dam, and we did it just far enough so that the slope from the top of the pipe to the check dam did not exceed 1 to 1.5 to create a solid slope. And Shannon, you can maybe just go to the next slide. Okay, so there you can see I've marked the rock, so you can find yourself on the pictures where what happened. So if you look on your right hand side, on the top, that was where the pipe outlet pipe was originally, which started the whole donga to form, and this happened quite in a short while. So it was really a big issue to stop the donga from the donga head, to stabilize that. And so we did the installation of the check dam based on our survey, which worked out perfectly. And the filling that you can see there behind the check dam, we used vetiver grass. I don't know if you're familiar with the vetiver grass. It's a sterile plant. It's not indigenous, but it's excellent for soil retention. It's for water purification. That is quite a good. solution for erosion. And it's a natural barrier against surface runoff. And there's the trick that we learned is that we, over time, it naturalizes the structure, conceals the baskets, and strengthens the whole system. So there is the end result is a slope that no longer erodes, a watercourse that loses energy gently because of the vetiver. And it is really a low-cost, very effective solution to stabilize soil behind gabion structures. There you can also see all the different markers to find yourself on the pictures, and where we planted the vetiver grass. So I've been there about a week ago, and those vetiver grass is now about 2.5 meters high, if I guess. So that donga head is stabilized and will never go anywhere in the near future, I suppose. If we go to the Shannon, we can go to the next structure now. Okay, that's the vetiver grass. Just to give you a bit of background on the vetiver grass. You can just look there on the side. The roots goes up to 3 meters deep, and it's sterile. It can't, like the hyacinths on the Hartbeespoort Dam, it can't spread, and so it's really a safe solution for stabilizing eroded areas and stabilize filling. Okay, so we can go to the next one now, please, Shannon. Okay, for the about the donga head, we did the install contour line gabion dissipation structure just to prevent water from concentrating and diverting it away from the donga. That dissipating structure we constructed it on the contour, and it is 70 meters long. And there you can also see the pipe outlet, which we moved back about 20 meters. We did a stilling basin there. So it is the donga is now stabilized. It's safe, and it won't erode anymore in the near future. Okay, so we can look at the next one, please, Shannon. Okay, the next one is a project close to the Kruger Park, just about 7 kilometers from the Kruger Gate. The development is Elephant Point, and it's located along the Sabi River near the Kruger National Park. And the whole issue was that they're building really upmarket villas. It's not called chalets or anything else. It's villas, so it's very upmarket on the embankment. And this embankment makes a tight about 90-degree corner turn there, which erodes that embankment. Eroded that embankment. You can see the jackberry trees there, which already about 30 degrees towards the stream, and which we managed to stabilize with the gabion structures. If you look on the next slide, please, Shannon. Okay, there you can see we started with the gabion matrices, which is the base of the gabions, which is, I think, the most important start. You can't really. That's the main reason why the gabion structure on the first slide failed, because they didn't install the gabion matrices. So the first is to put down your geotextile. You can also see on the third picture is the geotextile on the bottom and at the back. The gabion structure at the back was 3 meters high. We started with the base of 2 meters, and the next layer was 1.5 meter, and then the next layer was 1 meter. So you can go to the next slide, Shannon. Okay, there you can see we started with the next layer, and on the Gabion basket, the Gabion mattresses, and because was a very sandy area, we made the mattress 5 meters long. So it means the part in front of the Gabion basket, the main structure is about 3 meters. So there's no way that it can erode and damage the main structure or cause a failure. Okay, Shannon, next one, please. Okay, and then obviously you can see on the left-hand picture there you can still see the geotextile behind the gabions, and we were busy filling there behind the gabions to ensure that the slope is not more than 1 to 1.5, which is a safe slope to prevent erosion. And you will also notice that we filled the gabions on the left, on the right-hand side. We filled that it's a turn back into the embankment to make sure that the water can't get in behind the gabion structure. So the whole structure was 3 meters high, and it was the height is the same as the expected 1 to 100 year floodplain. Okay, next slide, Shannon. Okay, and to finish it off, we used the soil saver to reverse the topsoil that we removed from before we started. We stockpiled, and we used that topsoil to spread it out, and we stabilized it with soil saver. And I've also been there a while ago, and everything is nice and green, and the grass is growing. So we have a very happy client at the moment. So I think that's more or less the end of the presentation. Okay, yeah, the final outcome. Okay.
Thanks very much, Fanie. I see we've got Louis back, so maybe we can start again with Louis. And then if the audience has any questions, you're more than welcome to please put your questions in the Q&A. But I'll hand over to Louis now, and we'll continue the proceedings from there.
Great, thank you very much, Shannon. Appreciate it. I got it to the point where I was talking about the rock that we use for the gabions. I don't know how much you missed, so I'll just redo the chat. So we need a rock that's unweathered, of solid density, minimum solid density of 2.6 tons per cubic meter, and then size of the rock must be minimum size 100 millimeters. Is it not shared? Share. Did it kick me out again, Steph? Steph, did it kick me out again?
We can see your screen now, Louis. You can just put it on presentation mode.
Share there. That one. Okay, how's that?
Looking good. Thanks, Louis.
Okay, great. Thank you for that. Sorry about the glitch. So the correct sizing of the rock is very important to reduce the voids, and we don't want a rock that's too big and too small. So we can guide you on that. Our products we use, the gabions and mattress are our core business. Gabion rocks, we supply those as well for contractors to help them. Gabion tool sets, gabion barriers for the flood defense areas and military. We'll talk about that later. Hexagonal woven mesh, square weld mesh types of gabions, 2 different types. Also supply the biodegradable soil blankets on slopes to prevent soil erosion. And then the geotextiles are always used between the gabion and the soil to prevent loss of soil fines. And then we also now new innovations of Gabion lettering and numbering. So we'll show you all about that just now. But typical embankment protection walls are firstly the mass gravity wall, where you have a wall that's maybe 4 meters high. The base width is about 55% of the height, so 2 to 2.5 meters wide. And then we found these structures to at least 10% of their total height. So there's passive resistance in front of your toe, because there's 3 methods of failure for a Gabion structure: sliding, overturning, and overall slip stability. The second option, so that's the first option, the mass gravity wall. You can either have it with a stepped front face or a vertical front face. The second option is a stepped revetment wall, where we don't have a embankment failure possibility. It's just more of a surface erosion possibility. There we would use just a thin skin revetment to protect the local underlying conditions. And then the third option is in a reinforced soil, a fill situation for an embankment, where we're going to fill anyway. So we use gabions on the front face, either vertical or stepped front face, and then horizontal mesh tiebacks into the soil, that the soil is compacted on top of that, probably to 95–96% mod ashtray. And then the soil reinforcing element gives the soil the tensile properties it needs to upstand the embankment or not have slip stability failure. So those are the 3 main embankment protection measures we offer. Obviously, mass gravity walls are the most popular one, with woven mesh, slightly cheaper than weld mesh. Weld mesh is about 30 to 40% more expensive than a woven mesh gabion. 2 different types of mass gravity retaining walls. So you'd have the stepped front face or the vertical front face. We never really like having vertical front faced structures. We always rotate these gabion walls back to an angle of -6 degrees. In an area where we've got a gabion in a river, you need to protect the toe of the structure with mattress linings to take a point of scale from the toe of the wall to the end of the mattress. The mattress in this case is filled with rock, and it's flexible in nature, so you don't get erosion around and you don't get cracking of the structure if there's some slight settlement in river situations. Most rivers have a lot of clay, so you need to have a structure that's flexible. Clay walls in river courses just don't work. And then we've built some big structures for the mining industry, 15 to 18 meters high, near their primary crushers as well. So these are just some of the examples of walls we've done over the years: cladding of existing architectural walls, building of boundary walls, river protection in Uppington. We've done work all over South Africa, work in Dundee, Gabion weirs, longitudinal river walls next to rivers and roads. So gabions are very popular. This is just the sort of work that's being done in Germany at the moment. We've linked up with a German manufacturer to get their expertise as well. They use a much heavier, thicker mesh, 5 to 6 mil, with aperture of either 50/50, 50/100, or 75/75, probably a 5 or 6 mil mesh. And they only use the galvanized mesh. And because the mesh is so rigid, they don't have to pack the bigger rock in. They use a slightly smaller rock so that they can pour the rock in, so they can get much quicker installation times and reduce the labor component on site. Okay, this is just an example of the gabion with the mesh tail. It's made out of Class A galvanized material, all with PVC coating, and the length of the tail is determined by the height of the embankment. If you need any input on this, we can assist you, but these are quite common, and they're referred to as gab tail walls. This is some examples of gab tail walls that we've done in KwaZulu-Natal over the last years, showing the nice angular and curvature of the gabion and the step back, probably 150–200 millimeter step back of the structures, and then the geotextile behind the structures and below the walls to prevent any fines from the backfill material migrating through the structure and causing subsidence behind. So this is also quite important. This is a structure I designed and built through on the old Howick Road in Pietermaritzburg in about 1994, using the Gabion tail system. It's about 5 meters high, about 70, 80 meters long. These are photos taken last year, 30 years later. And as you can see, the vegetation has grown quite nicely over the structure, and the structure is still working well. Because it's in a dry situation, Class A galvanized, I had a look and there was no corrosion of any mesh, and it's still standing strong after 30 years. It's the sort of thing we like seeing. Obviously, we've done a lot of work with the mining fraternity for primary crusher walls, rivet diversion walls, conveyor belt protector walls, retaining walls. We've done a lot of work with different mining houses in Southern Africa. And obviously, gabions are very well used in riverine environments as transverse structures, or we call them weir structures, mattress linings with the mesh filled with rock and then lids placed on top, the flat top of gabion, you can see there, top right, the flat mattress, we call it, and then the gabion placed on top of it. On the right-hand side, you can see a typical 3D render of a gabion weir we did in Colonnades, Johannesburg, over the last 2-3 years. Now, mattress, we have the 3 different thicknesses: 170, 230, or 300 millimeter thickness. The general size of gabion we recommend is a 2 meter by 1 by 0.3, 2 meter long, 1 meter wide by 0.3 high, or 0.6 of a cubic meter volume. And then this one here at 12 times 0.3 is 3.6 cubic meter volume. As you can see, these mattresses have compartments inside, spaced every meter to reduce water velocities and reduce the movement of rock every 1 meter. So you generally place this mattress at right angles to the river flow to reduce your movement of rock during high flood conditions, because the lid must be placed on top and tied down and slightly overfilled, so you have a tightly packed mattress to prevent against any scour.
I'm not sure if Louis maybe has dropped off again. Clinton, are you able to maybe jump in from here?
I can, yes.
Okay.
I could potentially take over his slide and move from there.
That would be perfect. Thank you.
I can do that. That's fine. Let me just share my screen. Hi, everybody. Clinton here, General Manager at Gabion Baskets. So I'll just finish off what my dad was discussing now about the mattresses. So there's the 3 different options there. So we have a return on embankment mattress, where you would essentially excavate on the return over there. And then you have a gabion anchor mattress, where you would put an anchor into the soil at the top, and fencing standards, essentially where you would peg every meter or half a meter, depending on the height of the embankment. Just on to the next one. There's a couple of different embankment options with retaining walls and pegs in rivers, that sort of thing. So yeah, typical applications. And this is where essentially I would have taken over. So it's pretty much perfect timing. Okay, so I'll be discussing our installations and alternative projects and visual aspects of the business. So to start off, I'll continue with a job that we did about a year or 2 ago at Silver Star Casino. So initially there were some concrete blocks here that had failed on the embankment side here. It is a dry retaining wall. So we were called onto site to do 2 or 3 phases here. Essentially panning from about 4 meters high or 6 meters high down to about, I think it was about 6 or 8 meters high all the way through. So there's a nice photo there. So the foundation, essentially, I'll take you through a couple of steps on how we took about this project. Essentially, we had to remove all of the concrete blocks from the wall, excavate the embankment into the embankment, create a sturdy foundation, compact, put a 60% base width of height, and start building up. And we essentially attached onto the existing baskets because there was about a 40 or 50 meter long gabion wall that existed there already. So on the right-hand side, we attached onto that, laid down the geotextile, put on the gabion foundation, and then started building up. The first section was about 40 meters, and the second section, I think it was about 32 meters long by about 6 meters high. The challenges that we faced with this was that this was a massive job. So we were moving between 300 to 800 cubic meters of rock and fill at any given time. So we would essentially have to make space and provision for loads of rock to be packed into baskets, and removing soil and making space for that, as well as dumping it onto different sites that we would have to remove it off site. It was a very interesting project. It was a very nice project. It took us about 3 months, I think, for the first phase, and 3 to 4 months for the second and third phases. This photo here is a couple of examples of mass gravity walls similar to Silver Star Casino. As you can see here, Silver Star Casino, a couple of river walls, mass gravity walls made out of woven and welded mesh. I'll move on to river retaining walls. So this is another project that we did called the Colonnades, which my dad has already brought up. Where I'm going to go into 3 different phases. So to show 3 different aspects of river diversion, river retaining, and channelized weirs and river courses. So phase 1 was essentially a 40-meter long retaining wall by 1.5 meters high. We laid down a mattress over here as your foundation, with the excavated embankment with the geotextile behind and below the structure running for that 40 meters. So essentially what was happening here was the municipal water was coming into the complex from the top, and it was scouring away this embankment here, which was going to start damaging the property and the walls there on the boundary line. So we built that up out of the PVC coated woven mesh with the standard rock. It took us about 2 to 3 weeks, and we were completed on site. Phase 2 was also a small retaining wall about 10 meters long and a channelized water course, essentially where we protected embankments just by lining the channel with mattresses. It was about 22 meters long, and we managed to retain both sides of the soil because it was scouring away on both sides, and there were properties on both sides which the complex was worried about. Phase 3, so down the river channel in the complex, they have this channel running throughout the entire complex basically, and on both sides there are private houses there. So essentially every 20 to 30 meters they would have an existing concrete weir built that we would basically retain and create channelized sections to divert the water and channelize the water to prevent it from scouring around into the other properties. So this section here is just a typical inlet weir, which we had built with mattresses and gabions on either side. This is the same company in Germany, essentially showing how they would build their weirs out of the welded mesh. Similar concept to ours. It seems as though they use the welded mesh instead of the woven mesh. But I mean, both work in their different ways. We would obviously suggest a woven mesh because it is more flexible, but this seems to be working quite well. Okay, so moving on to another topic called Bailey bridges. So Bailey bridges are a rapid bridge deployment, which they've been used since World War II. Essentially, they are support structures that combine a strength of modular bridges and gabions. So they're used for rural infrastructure development, disaster relief, military defense, mining, and industrial access. So it's rapid deployed bridges with gabions that retain on both sides. I'll show you a couple of examples of our gabions being used here. So these are essentially gabion retaining walls. We also use gab tails here. So essentially with the mesh tail tying back into the embankment on both sides. And you can see here, this looks like it's about 4 meters high, and it's a vertical front face on both sides. It can be vertical front face here because we already have the gab tails in to support the structure on the inside. Bailey bridges. Okay. So this is a little bit more information on the Bailey bridges. They're available in single lane configurations up to 35 meters in length. They are galvanized steel frames, incremental launch installation. We obviously implement the gabion mattresses and retaining walls, and they are utilizing solar powered lighting options. Okay, next product alternative that we can supply. So generally on embankments and big mountains where you have a lot of rock and debris that's falling onto roadsides or, you know, onto people's property, we would suggest rock form mesh netting, where we would essentially tie the mesh onto the embankment to catch those rocks to prevent them from falling onto roads and cars and that sort of thing. So it's a form of retaining as well as protection. As you can see here, this is how it works. These are your cable locks, which you would bolt into your rock. You would essentially bolt that on. It's made of high tensile strength mesh. It acts as, like I said, acts as a barrier to contain falling rocks, and it absorbs the impact of rocks to prevent reducing the potential for damage. So where it is used, highways, construction sites, slopes, railings, mining operations, and urban areas near cliffs. So discussing some of our new products, we have 2 new products that are relatively new in the market. They have been seen around, but we have taken the initiative to take it one step further and develop them a little bit more. You can have a look on our website for more information. So gabion lettering and numbers, we do them in 0.5 meter and meter heights, and any letter or number of the alphabet can be done. So it's a fresh take on traditional signage, crafted from high quality, galvanized, and we can also do powder coating in any color as well. This is a new take on boundary walls or freestanding gabion walls. So a gabion slimline boundary wall is only about 70 to 100 mils thick. We use the welded mesh look here with a 19 millimeter diameter structure, and yeah, it can go up to about 2 to 3 meters from what we've seen. A similar product which we've used is wall cladding. So essentially, you would take a welded mesh and roll bolt it onto an existing wall structure. And we've done a couple of wall cladding structures where we've gone up to 4 to 6 meters. You could potentially go up any height as long as your structural stability is there. And the nice thing on this is, you know, the feature, it looks great as a feature. It adds to the look of your building. So aesthetically, this looks really nice. And the width you can go down to maybe 250 mils thick. So it's also a bit of a save on a cost there rather than building a full half meter or meter width freestanding wall. So same thing, wall cladding, aesthetically appealing, flexible, environmentally stable, and yeah, durable. So many benefits of using that. Like I said, I think the aesthetic appeal would probably be your main factor. So international wall cladding, it looks like we all follow a similar principle. Same company, Rothfuss in Germany. Essentially, you would have your vertical and horizontal supports, angle iron or steel framing to support that, because you're probably looking at around 10 meters high there, so you need some structural stability there. Another product that we offer for coastlines is obviously your sandbag as well as fiber rock bags. So during the course of the floods in Durban, these fiber rock bags were quite a lot more natural than utilizing gabions on sea sand, because essentially they would break open and rock would fall out onto the sand. So these fiber rock bags, you fill them with local sand, and you can essentially pack them and as a retaining wall to protect the beach embankments. Yeah, so robust, what do they offer? Robust protection, they're eco-friendly, so environmentalists like them. They have long-term durability. They can last, I think, up to 20 years, 30 years, so a very, very long time, and lots of customizable solutions. Another alternative product, which Fanie has mentioned in his job in the Kruger, is the biodegradable soil blankets. These would be used on your embankment to vegetate, essentially, rather than using a retaining wall where you could save a bit of costing. You build maybe your gabion half of the height and then slope it back so that you could vegetate the embankment behind it. So they can be hydro-seeded. It prevents erosion on steep soil slopes, very environmentally friendly and quick and economical to install. So you would just basically peg them into the ground. So with bread comes your butter. Gabions essentially would always come with geotextiles. So geotextiles is a filter fabric which we use to line anywhere a gabion touches soil. So behind and below your gabion structure, we would line that structure with geotextile. So essentially what that would do is it would prevent soil from washing through your baskets and allow for water to flow through. And generally it covers 1 to 2 squares of per cube of gabion on installation sites as a rule of thumb. What can it be used for? Like I briefly said, filtration for mattresses and gabions, drainages, roadway lining, and membrane. So Gabion Barriers utilizes multitude of our different products. So our Gabion Barriers are also a sort of new product that we've brought into the market for rapid deployment in military solutions or even erosion. So they're suitable for filling earth, sand, gravel, crushed rock, and other granular materials. So they can essentially be filled with basically anything that you have on site. And they basically are either folded or in a concertina. So you would pull them out and rapidly open them up and fill them, either by hand or with a TLB or a bobcat, something like that. Yeah, it's easier to fill with construction equipment using 2 to 4 people. So less labor on site and quicker to install. Here's a couple of photos of typical uses of the barriers. So they can be used for military and flood control. As you can see here, here is some barriers holding back some water with a bit of lining there. Same here. And here it's being used in military defense cells. So protection of local troops or, barricades, that sort of thing. So a little bit more about our services, what we offer. technical presentations, which we can do practical site training, structure design, full installation, animations and 3D visualizations, and yeah, Gabion training, as I said before. Okay, so I'll go into a little bit of what we offer and what I specialize in. So I studied 3D visualization and 3D architectural visualization and animation. So essentially what a 3D visualization is it's a rendered image of something that I would build up, you know, before something is implemented on site. So essentially the client or the contractor would have an idea, send me a design, some photos, or I'd go onto the site and take a few photos, measure up, and essentially build up that into 3D and superimpose the proposal onto the 3D visualization. Here's a couple of examples of where it would be implemented. A house, some freestanding walls, boundary walls, planters. Ironically, here we have a mention for Fanie. This was one of his jobs where I actually partnered up with him for the first time. I went onto site, took up some photos, and rendered that in 3D for him, just so that we could have a look what it would look like. So that's essentially what the 3D visuals do. Installation. So we've recently started doing full installation on site. We have project managers that manage the job. So we would go out to site, price the job, supply the gabions, rock, and the labor to site, do full inspection before, during, and after, and we can offer full sign-off with Fanie Joubert in our chat. So civil, architectural, and landscaping solutions. We've partnered with Checker Training to offer certified training for local communities. We also offer the toolkits on site so that they can be built up properly, you know, facilitating workmanship, faster installations, and, you know, empowering and enabling skilled and unskilled workers. So going into how we build our baskets. So essentially we would cut them and lace them. So we have two different closing methods, which I'm going to run through quickly with you now. So this is the traditional lacing method. We would use binding wire to lace the basket. So this is a little bit more manual process. It's one of the original ones, but the strength and stability of this is really good. The connection of the panels ensures that the basket can withstand the weight, because obviously when you're packing the basket, you need to make sure that you lace and you brace your baskets correctly. So yeah, as I said, the bulging, you want to prevent that from bracing and lacing your baskets correctly. The other method would be the hog ring clip. So we have a manual and a pneumatic hog ring gun, essentially, which we would use. This speeds up the process quite dramatically. We usually use this on the welded mesh, but it has been implemented into our woven mesh production line as well. So as it says here, your speed, strength, appearance, and labor savings are your major factors in your hog ring method. How to install a gabion. As you can see, this is basic animations to show you how we would build up a basket. It would come to site flat packed, and then you would use your binding wire or lacing hog ring clips, connect them together, and then tie them together, filling them with rock once you have prepared the site. And then this is the technique showing your bracing method. So every say 30% or third of the way, you would pack your rock and then brace it so that you prevent the bulging. And this is how you would prepare your sites. This would be your section view of how you would prepare and pack your gabions up on an embankment. and then you can also vegetate it there. This is a quick video on river mattresses. Similar concept, except the height of the basket is different. Where you're looking at, you know, a meter or half a meter there. This is about 170 to 300 mils of height. So it's a similar concept with your lacing of your mattresses. You would prepare your soil with the geotextile, lay your mattresses down, connect them together, and then fill them with rock. On an embankment or channel lining, it's not necessary to brace that often or really at all, because the height is only 300 mils. And this is essentially closing your lids. So lids would generally either come attached or as separate entities. That's a little bit more technical info for you guys there when we send out the presentation. Just shows you the steps of how to install a gabion and a mattress from bundle to gabion wall. Same with the mattresses, and then the filling of gabions as well. This just shows you how you would phase into your different gabions of, you know, packing your baskets, your bracing methods, lacing and bracing, and filling your baskets. Just two more quick videos. These essentially show in quick how you would assemble your gabion barrier. This is a concertina animation on how to unfold your concertina basket and fill it with a bobcat on site. So obviously it's probably not going to be this quick, but it does allow for rapid deployment and installation on site. So that's how you would install a concertina. We have another option of folded, which is basically the same thing, except you would unfold the basket on site, open it up, and then fill it with whatever you have that you can use, sand or rock, rubble, that sort of thing. And that can be stacked together and basically go up to 2 or 2.5, 3 meters high. Okay, and that brings us to the end of the presentation. There's all our contact details. If you need any information, you can contact us. Thank you very much.
Thanks, Clinton. That was so interesting. All of these presentations were so interesting. I think now, if you want to, we can move to the Q&A. I'm not sure if Louis is able to come back on the screen. Maybe he can take the questions. Otherwise, I'm more than happy to help out with that.
I think you can come back.
Louis, are you there? Ah, there we go.
Yes, I'm here. Sorry about the glitches.
No problem. Would you like to go ahead with the questions?
Yes, they're on the right-hand side, yeah? I see the first question is, being steel-based, even if galvanized or PVC or other coated, the basket should eventually corrode, degrade, or even fail. How would you or should you eventually be borne in mind at the outset? This is from Neville. This is a common question we have about gabions. People are worried about the corrosion of the mesh in a period of time after construction. In a dry situation, the Class A galvanized mesh, either woven or welded mesh, is quite suitable to last 40, 50, 60 years, or permanent. In riverine environments or near coastlines or in mining situations, we prefer to go for the Class A galvanizing plus the PVC coating. And that's going to give you a design life of about 60 years. If you want something longer than that in an extreme situation, then you need to be considering the Galfan material or the Alu zinc material with PVC coating to give you a design life of 120 years plus. Obviously, at the time that the basket starts degrading, the theory is, especially in river courses, the voids are going to be filled with soil, and you're going to get growth and vegetation, and the vegetation roots will tend to stabilize those structures as well. So You know, in a river run environment in 20, 30, 40 years time, it'll be totally solidified with silt and it's basically achieved its task. I also wanted to just say that if you have any questions, you're welcome to contact us afterwards. We're going to send out this presentation to everybody who wants it. And we obviously also have a website with more information on it. And we also have a YouTube channel that you can review the installation methodology, the animations, and the guidance so that you can show that to your people when they're tending to want to construct baskets on site. What is the cost on site inspection and advice? We normally charge a small fee of 750 Rand for a call out. A close one, obviously, if it's further afield, we charge more. But generally, we're very happy to assist you with advice and guidance and designs and quotes anytime.
Louis, if you also
as far as
click
the
on
questions,
Q&A at the bottom of your screen, you'll also see some questions that came
yes,
through from there.
Okay, Layla seems to want to know the most common modes of failure for Gabion structures. I've already said that the main modes of failure for mass gravity or retaining structures are sliding forward of the structure, overturning of the structure, and overall slip stability of the structure. The fourth mode of failure could be foundry conditions or your bearing pressure of the in-situ soils that needs to be checked, and then individual sliding of the different layers of the baskets. And that's why it's very important that the people know how to install these baskets correctly. And this is something we assist with so that your structure, the money you've spent on it is well worth it and paid for. The geotextile is either made from a polyester or a polypropylene in South Africa. Just a question about the geotextile, what it's made from. So the geotextile, really the main purpose of that is to allow the through flow of water, but to stop the movement of soil and create a settlement in these conditions. Yvette Retief asks a question, will the gabions prevent water from a biogas project next to it in case of storms, and the biogas project is built upon dolomite, which for years slow to show degradation, but despite the project was approved? I was thinking of a tail dam wastewater overflow and has disastrous effects on the river and wetland close to the project. Yeah, Yvette, you can contact us afterwards to discuss this one. It's more complex. Okay, I don't know too much about vetiver grass. You'd have to speak to Fanie about the vetiver grass material. I think that's it from the questions. We'd like to thank everybody for attending, and sorry for the glitches with the internet, but thank you very much.
Thanks very much. While I've got you on here, Fanie, would you like to give some information on the vetiver grasses?
Okay, what's his question, Shannon?
They're just asking, one person asked, I just want to find it quickly. Can vetiver grass be planted in any ecosystem? Cheyne says that she likes to implement green solutions for storm water management plans, but is unsure if stiff grass barriers are allowed, and if the grass species is not native to the ecosystem, what sort of problem could that have? I think she's just asking in general about that system.
Okay, Shannon, thanks. I'm a bit more prepared now than previously. Yes, the vetiver can actually be used in any environment because it's not invasive, it's sterile. You can only plant it from a plant. So you do need a shoot or something to plant it. But it depends on, like for the instance, the project in which we did close to the Kruger. There we're not allowed to use vetiver because it's nature reserve or whatever. But everywhere else, because it's such a hardy and plant, we will never use it without the gabions. It's just an add-on for the gabions to stabilize the filling behind the gabion baskets, or in wetlands, or it's excellent for wetlands to purify water. And it can basically grow in any soil from a pH of 3.3 to 12.5, and it's drought tolerant and temperature tolerant, and the roots actually grows up to 3 meters deep, actually more, 5 meters deep. And like I said, the plants that we used on that donga, it's basically about 3 meters high above the ground now. So if you plant it close together, it's something that contains the soil and will actually build up. So never use it without gabion baskets, definitely, and use it to stabilize filling. But you can use it for in any environment, as long as it's something that you have to find out from the client or where you are actually doing the project. But yes, yeah, so it is, I think we've used it in different environments, but I know, for instance, in the Kruger, or that project near to the Kruger, we won't be allowed to do that. So yes, yeah, that's because it's not a sterile plant. You can basically, it's not something that can reproduce.
Thanks very much for that, Fanie. Before we close off, I'd just like to sort of go around the room and see if anybody has some final closing points they'd like to make. Shall I start with you, Clinton? Anything you'd like to close off with?
No, I think I've had what I needed to say. I've said what I needed to say. If there are any outstanding questions, Shannon, just get the guys to send them through to us, and we'll be happy to assist directly. That's not a problem. But thank you for your time, and thank you to everyone that joined. I hope that we gave a little bit of knowledge out there about our business and products and services. So thank you for your time.
Thanks, Clinton. Fanie, I'll move to you. Have you got any final words you'd like to share?
I think what Clinton said, and it's important, planning is important. So we get many times clients that inquire about gabions, and then you can actually hear from what they need is that they don't know what they're actually doing, and they're not getting all the products. For instance, after floods, you will get the farmers to call you and they want gabion baskets. And then if you ask them about the mattresses, they will say, no, they don't know that stuff. And the same with geotextile. So for me, it's important to actually try to understand what the client is looking for, and to help him and to guide him if I can see that he's going in the wrong direction. Because like you've seen on my first slides, gabion structures fail definitely if you don't do the right thing. So and then if it fails, it's gabion baskets. It's not because you did the wrong thing. It's because it's gabion baskets. So please always planning and get advice. If you don't know everything about gabions, between me and Clinton and Louis, I think we will be able to head you in the right direction, and to make sure that you build a structure that will last forever.
Wonderful. Thank you, Fanie. We'll share your contact details with everybody after the event as well. And then finally, Louis, your last words.
Thank you very much. We'd like to thank everybody for joining us and listening to some of the information we had for you. It's our pleasure to do so. We have a lot of passion for our business and a lot of opportunity. But please, if you have any questions after this, we're going to share the presentation, and please contact us for more information in regard to what we've discussed today. Thanks so much. Appreciate it. Thank you, Shannon.
Thank you very much to all our panelists, and thank you also to our attendees for joining us today. It's really been a pleasure sharing the topic of Gabion solutions and innovation with you. Before we wrap up, I'd like to extend my gratitude to our moderator, Louis Cheyne, and guest speakers, Clinton Cheyne and Fanie Joubert. If you're interested in hearing more about Gabion Baskets, please visit the website at gabionbaskets.co.za. And with that, I'd like to bid you all farewell. Thank you very much for your time and for joining us.